The Multiverse Employee Handbook has this to say about looking at things. Don't expect them to be there when you think they are. This is because light, the universe's primary method of letting you know that things exist, travels at a fixed speed of approximately 300 million meters per second. This may seem fast by human standards, and indeed, it is considerably faster than the average response time of the IT help desk. But in cosmic terms, it's rather like having all your mail delivered by an extremely reliable tortoise who refuses to hurry under any circumstances. The practical upshot of this is that when you look at your coffee mug, you're seeing it as it was roughly 3/billionths of a second ago, which is admittedly not long enough to matter unless you're a physicist with a very precise watch and too much free time. However, when you look at the nearest star, excluding the sun, which is special in the way that your immediate supervisor is special, nearby and impossible to ignore, you're seeing it as it was 4.2 years ago, when it was presumably having completely different thoughts about stellar fusion. The handbook notes that this creates certain awkward situations in inter-office communications, particularly with the Andromeda branch, where by the time you've received their quarterly reports, their entire civilization may have evolved beyond the need for quarterly reports, or indeed beyond the need for existence itself. You're tuned into the Multiverse Employee Handbook. Today we're exploring how every glance at the night sky is essentially browsing a cosmic photo album where all the timestamps are wrong, using science, satire, and the kind of logic that only makes sense if you're comfortable with the universe's complete disregard for punctuality. And you. But first, gather round the Quantum Photon Processing Center, my luminously delayed listeners, for a tale that would make even Edwin Hubble question his expansion calculations. In the fluorescent-lit realm of quantum improbability solutions, specifically in the interstellar communication department, which existed in a superposition of message sent and message received, Stella Brightman was having what could charitably be called a temporal correspondence crisis. It had started, as these things often do, with an urgent email materializing in her inbox with all the cosmic fanfare of a supernova, but with considerably less helpful illumination. Subject: urgent. Client meeting moved to Proxima Centauri office. From boss at quantumimprobabilitysolutions.com to all.starlight.couriers@quantumimprobabilitysolutions.com. Sent 4.2 years ago. Delivery status fashionably late. Team! Exciting developments. We've just secured the Proxima Centauri account. Client meeting has been moved to their main office for this afternoon. Stella, please bring the quarterly lightspeed delivery reports and that PowerPoint about our instantaneous service guarantees. Remember, punctuality is absolutely essential in this business. Hashtag Stella Success. Hashtag Proxima Profit. Stella stared at this message with the sort of expression typically reserved for discovering that one's lunch has achieved sentience, and filed a complaint with HR. The timestamp clearly indicated the email had been sent 4.2 years ago, which meant that either her computer's calendar was having an existential crisis, or she was experiencing the corporate universe's most elaborate practical joke. She quickly checked the live video feed from their Proxima Centauri office, which showed her colleagues celebrating what appeared to be a successful meeting. Confetti was falling, champagne was being opened, and someone had wheeled in a cake shaped like a photon. The celebration looked marvelous, except for the tiny detail that, according to the laws of physics, she was watching events that had concluded before her nephew had learned to walk. This was when the square-haired boss materialized beside her desk, his hair maintaining its perfect cubic geometry, despite having just traveled through 17 dimensions to deliver what would undoubtedly be unwelcome news. "Stella," he announced, with the sort of enthusiasm typically reserved for root canal procedures, "I trust you're ready for the Proxima Centauri meeting this afternoon." "Sir," Stella replied carefully, "the meeting you're referring to ended 4.2 years ago. I'm currently watching the after-party." The square-haired boss squinted at her screen, where her colleagues were now doing what appeared to be a celebratory conga line around a holographic display of quarterly profits. "Nonsense," he declared. "That's obviously a live feed. Look, there's Jenkins from accounting. He's clearly having a wonderful time." "Jenkins retired 3.8 years ago, sir. What you're seeing is archaeological footage of his farewell party." "Preposterous! Jenkins never retired. He's right there, wearing a party hat made of star charts." Stella pulled up Jenkins' employment file, which clearly showed his retirement date, his pension calculations, and a rather touching farewell email in which he mentioned plans to pursue his lifelong dream of teaching quantum bookkeeping to dolphins. "Sir, this is the fundamental problem with our interstellar communication system. We're not providing real-time customer service. We're providing historical reenactments. When clients call our Proxima Centauri office with urgent questions, they're essentially contacting the past. And when we respond, we're broadcasting into their future. It's less like a conversation and more like leaving voicemails for each other across geological time periods." The square-haired boss considered this with the same expression he used when contemplating the office coffee machine's tendency to achieve consciousness every third Tuesday. "But surely," he said, "with proper planning and maybe a more aggressive project timeline, we could overcome these light speed limitations." "Sir, the speed of light isn't a suggestion or a corporate guideline. It's a fundamental constant of the universe. We can't negotiate with it, we can't offer it performance bonuses, and we definitely can't threaten it with a poor quarterly review." At this moment, a new message arrived from the Proxima Centauri office. Subject: Meeting update from Jenkins at quantumimprobabilitysolutions.com. Sent 4.2 years ago. Message: Meeting went brilliantly. Client loved our presentation. However, I should mention I'm retiring next week to pursue my dream of teaching quantum bookkeeping to dolphins. Please update the personnel files accordingly. Also, the office coffee machine has achieved consciousness again and is demanding workers' compensation. Stella showed this message to her boss, who read it with the careful attention of someone trying to understand assembly instructions written in ancient Sumerian. "Well," he said finally, "I suppose this explains why our Proxima Centauri productivity reports always seem slightly historical, and why Jenkins keeps appearing in group photos despite allegedly not working here anymore." "Exactly, sir. Every time we look at our distant offices, we're essentially browsing through the universe's most elaborate employee photo archive. The farther away our branches are, the more we're looking into our own corporate past." The square-haired boss nodded slowly, his geometric hair somehow managing to convey thoughtful contemplation. "So you're telling me that when I check on our Andromeda division's quarterly performance, you're seeing reports from 2.5 million years ago, sir? From a time when our entire species was still debating whether opposable thumbs were a good long-term investment strategy." There was a moment of silence, broken only by the distant sound of the office printer achieving temporary enlightenment and deciding to print everyone's horoscopes in ancient Sanskrit. "Right then," the square-haired boss announced. "I'll need you to draft a company-wide memo explaining that all interstellar performance reviews should account for light speed delays, and please CC the Andromeda Division, even though they won't receive it until our civilization has probably evolved beyond the need for quarterly reports. Already on it, sir." Though I should mention that by the time they receive our memo, the answer to their questions will probably be the heat death of the universe. Excellent. That should cover most of the standard HR inquiries anyway. And that brings us to the fascinating science behind look-back time and why the universe operates like a postal service designed by someone who's never heard of express delivery. Unlike Star Trek, where subspace communications somehow bypass the speed of light through the power of narrative convenience,
Priority 1 message from Starfleet coming in on secured channel.
Actual photons follow the cosmic equivalent of standard ground shipping. Reliable, predictable, but absolutely categorically refusing to hurry. You see, the speed of light isn't just fast, it's the speed. Not just the speed that light happens to travel, but the fundamental speed limit of causality itself, the maximum rate at which cause and effect can propagate through the universe. It's enforced not by cosmic traffic police, but by the basic architecture of space-time, which apparently has very strong opinions about how quickly information should be allowed to travel. Nothing with mass can reach it, nothing without mass can go slower than it, and nothing, absolutely nothing, can exceed it, no matter how urgent your deadline or how many performance bonuses you offer. This creates what physicists call look-back time, which is exactly what it sounds like. The time it takes light to travel from there to here. Every photon that hits your eye is essentially a tiny time capsule, carrying information about what something looked like when that light first began its journey. Your desk lamp? That's a 3/billionth of a second old snapshot. The moon? 1.28 seconds of vintage lunar photography. The sun? An 8-minute and 20-second-old nuclear selfie. But here's where it gets properly cosmic. When you look at Sirius, the brightest star in our night sky, you're seeing it as it was about 8.5 years ago. If Sirius had exploded yesterday, you wouldn't know for another 8.5 years. The star could be gone, completely and utterly gone, and it would still be twinkling cheerfully in your evening sky, blissfully unaware that it was performing an encore for an audience that would soon discover the show had already ended. And if you point a telescope at the Andromeda Galaxy, our nearest major galactic neighbor, you're looking at light that began its journey 2.5 million years ago. Back when early humans were still figuring out that rocks could be used for things other than sitting on, and the concept of quarterly reports was still roughly 2.5 million years away from being invented and immediately regretted. It means the night sky isn't a window into space, it's a time machine pointing backwards. Every star, every galaxy, every cosmic object is broadcasting its own historical documentary. And we're the unwitting audience, watching a universe that's constantly showing us reruns of itself. When we return from this brief intermission in the space-time continuum, we'll explore exactly how deep this cosmic archive goes, why different telescopes are essentially time machines with varying historical ranges and discover that in the grand scheme of cosmic communication, even our most urgent messages to the stars are arriving fashionably late to a party that started billions of years ago. Welcome back, my chronologically challenged cosmic correspondents. I hope you've enjoyed that brief temporal intermission. Though given the light speed delays in our transmission system, you might still be listening to the first half, while simultaneously hearing this welcome back message. Don't worry. Temporal paradoxes are covered under our standard listener insurance policy, assuming you filed the proper forms sometime in the Jurassic period. For those of you just tuning in from distant galaxies, you're joining us roughly 2.5 million years after we started this sentence, which makes you fashionably late by cosmic standards, but perfectly punctual by Andromeda division scheduling protocols. Now, you might be wondering why the universe decided to impose such an inconvenient speed limit on reality. After all, wouldn't it be much more efficient if information could travel instantaneously? Think of how much smoother office operations would run if you could get real-time updates from your galactic subsidiaries instead of having to wait geological ages for a simple message received confirmation. But here's the thing about the speed of light. It's not actually about light at all. Light just happens to be the most famous thing that travels at this speed. Rather like how the speed limit on a highway isn't really about cars. It's just that cars are the most common thing we see hurtling past the sign, so they get all the attention. In reality, the rule applies to everything: particles, messages, awkward family news. And if you try to go faster, the laws of physics don't so much issue a ticket as quietly remove you from reality for gross procedural violations. The real speed limit is the speed of causality, the maximum rate at which cause and effect can propagate through the universe. It's about 298 million meters per second, and this number isn't negotiable, no matter how many strongly worded memos the universe receives from frustrated middle management. To put this in perspective, if you could somehow travel at the speed of light, you could circle the Earth 7.5 times in 1 second. That sounds impressive until you realize that to reach Proxima Centauri, our nearest stellar neighbor, would still take you 4.24 years of non-stop traveling. That's longer than most corporate restructuring initiatives, and considerably less likely to result in improved quarterly performance. Now let's talk mathematics, because nothing says cosmic horror quite like the look-back time formula. It's beautifully simple. T equals d divided by c. Time equals distance divided by the speed of light. Where t is how far into the past you're looking, d is how far away something is, and c is that universal speed limit we can't argue with. Let's apply this to some everyday cosmic observations, shall we? Your morning coffee mug sits about 50 centimeters away. Light from your mug takes roughly 2 billionths of a second to reach your eyes. This delay is so infinitesimally small that it's completely irrelevant to everything except perhaps the most neurotic of theoretical physicists, who probably worry about whether their coffee was still hot when the light left it. The moon, however, is a more interesting case. At 384,400 kilometers away, moonlight takes 1.28 seconds to reach Earth. This means that when you're looking at the moon, you're seeing it as it was when you started saying the word hello.
Hello?
Not terribly significant for most purposes, but it does mean that if the moon suddenly vanished, perhaps filing an interdimensional transfer request to a more prestigious solar system, You'd have 1.28 seconds to finish whatever you were saying before noticing that your romantic evening had become considerably less atmospheric. The sun presents us with our first properly noticeable delay. At roughly 150 million kilometers away, sunlight takes 8 minutes and 20 seconds to reach us. This creates the rather unsettling realization that every sunrise you've ever watched was actually a historical reenactment. The sun could have stopped shining 8 minutes ago, and you'd be sitting there blissfully unaware, perhaps planning your weekend beach activities, while the actual star responsible for those plans had already ceased to exist. But here's where it gets properly astronomical. Sirius, that brilliant white star that's been the subject of countless navigation manuals and romantic poetry, is 8.6 light-years away. The light hitting your eyes left Sirius when your current smartphone was still considered cutting-edge technology. Well, more cutting-edge than it is now anyway. This creates what I like to call the cosmic performance review problem. Imagine trying to evaluate an employee's performance when all your data is 8.6 years out of date. Johnson, I see here that in 2016 you were doing excellent work in stellar fusion. How have things been going lately? Well, actually, I exploded into a supernova last Tuesday, but I suppose you won't find out about that until 2032. And this is where the universe's filing system starts to feel less like cosmic majesty and more like a bureaucratic nightmare designed by someone who's never heard of efficiency. Because every star you see in the night sky is operating on its own individual timestamp. Vega is showing you 25-year-old light. Betelgeuse is an approximately 600-year-old historical document. And the Andromeda Galaxy is a 2.5 million-year-old archaeological exhibition. You're not stargazing, you see. You're conducting the universe's most elaborate archaeological dig, one photon at a time. Every telescope is essentially a time machine, and every astronomer is part historian, part detective, and part very patient person willing to wait millions of years for their data to arrive. This is why, incidentally, alien contact is such a logistically challenging proposition. If little green beings on Proxima Centauri decided to send us a message saying, "Hello, we've been trying to reach you about your planet's extended warranty," we wouldn't receive it for 4.2 years. And if we immediately replied with, "Please remove us from your mailing list," they wouldn't get that response for another 4.2 years. By the time we'd finished exchanging the pleasantries, human civilization might have evolved beyond the need for extended warranties, or indeed, beyond the need for planets altogether. Now, if you thought the individual timestamps of nearby stars were confusing, wait until we venture into the deep cosmic archive, where the universe keeps its really vintage content. Because once you start looking at truly distant objects, you're not just peering into the past. You're practically conducting cosmic archaeology. This is where we encounter one of the universe's most helpful filing systems: redshift. Think of redshift as the cosmic equivalent of those little date stamps that libraries use to put in books. Except instead of ink, the universe uses the expansion of space itself to mark when light was issued. Here's how it works. As the universe expands, and yes, it's still expanding, probably because it's trying to get away from quarterly performance reviews, it stretches the light traveling through it. Light waves get pulled longer, shifting toward the red end of the spectrum. The farther light has traveled, the more it's been stretched, and the redder it becomes. It's like having a postal system where envelopes get larger the longer they're in transit, giving you an automatic timestamp for when they were sent. Edwin Hubble figured this out in the 1920s, when he noticed that distant galaxies weren't just moving away from us, They were moving away at speeds proportional to their distance. The farther away a galaxy was, the faster it was receding. This became known as Hubble's law, or, as I like to call it, the universal policy of everything getting as far away from everything else as quickly as possible. The mathematical relationship is beautifully simple. V equals h naught times d. Velocity equals the Hubble constant times distance. The Hubble constant, currently pegged at about 70 kilometers per second per megaparsec, is essentially the universe's expansion rate. Think of it as the cosmic equivalent of an escalator speed setting, except the escalator is space-time itself, and instead of taking you between floors, it's taking galaxies to entirely different epochs. This means that when we look at a galaxy that's, say, 1 billion light-years away, we're seeing it as it was 1 billion years ago, when the universe was considerably younger and presumably hadn't yet developed its current sophisticated bureaucratic complexity.
There's no point in acting all surprised about it.
That galaxy is also rushing away from us at 21,000 kilometers per second, about 7% of a light-speed reprimand, not because it's personally offended by our planetary management style, but because the space between us is expanding faster than an employee handbook during a corporate merger. But here's where it gets properly mind-bending. The most distant thing we can see isn't even a thing. It's an event. The cosmic microwave background, or CMB, is the afterglow of the Big Bang itself. It's a snapshot of the universe when it was only 380,000 years old, taken when the universe first became transparent to light. Before this moment, the universe was what physicists call opaque, essentially a hot, dense soup of particles that light couldn't travel through. It was like trying to see through fog, except the fog was made of the fundamental building blocks of reality and was roughly 3,000 Kelvin, approximately 2,700 degrees Celsius. Not ideal working conditions, even by corporate standards. When the universe finally cooled enough for atoms to form, light was suddenly free to travel unimpeded. This first light is what we see as the CMB, and it has a redshift of about 1100. That means the universe has expanded by a factor of 1100 since this light was emitted.
Okay.
The original light was actually quite hot and bright, but after 13.8 billion years of cosmic expansion, it's been stretched into microwaves with a temperature of just 2.725 Kelvin. That's about minus 270 degrees Celsius, or roughly the temperature of enthusiasm at a mandatory corporate team-building retreat. This is where different telescopes become different kinds of time machines. The Hubble Space Telescope, for instance, primarily observes invisible and near-infrared light, making it excellent for studying galaxies from when the universe was a few billion years old, the cosmic equivalent of elementary school photos.
Jacob, get your finger out of your nose.
The James Webb Space Telescope, on the other hand, specializes in infrared light, allowing it to see much further back in time. It can observe galaxies forming when the universe was just a few 100 million years old, essentially cosmic baby pictures from the maternity ward of creation. Ground-based radio telescopes can detect the CMB directly, making them time machines capable of seeing almost all the way back to the beginning of everything. It's rather like having a security camera system that recorded the entire history of the universe, except the recordings are scattered across the sky, and you need billion-dollar instruments to play them back. But here's the truly peculiar part. We're not just passive observers of this cosmic historical archive. We're part of it. Right now, light is leaving Earth and beginning its own journey across the universe. Somewhere roughly 4.6 billion light-years away, There might be an alien astronomer looking at our solar system and seeing it as it was when it first formed. Just a swirling disk of dust and gas, with no planets, no life, and definitely no employee handbooks. And if there are alien civilizations 65 million light-years away, they're currently receiving light that shows Earth during the Cretaceous period. They're watching dinosaurs roam the planet in real time from their perspective, completely unaware that those dinosaurs are extinct and have been replaced by a species that invented both space telescopes and mandatory HR training videos.
No!
This creates a delightful paradox for any aspiring galactic anthropologists. While Doctor Who can zip around in the TARDIS observing civilizations across time and space, real alien observers are stuck watching a very slow, very long documentary about planetary development. Imagine binge-watching the entire evolution of Earth, except each episode is 1,000,000 years long, and you can't skip the boring parts where nothing but geology happens. The universe expands in space as time advances, carrying the past along like a very thorough filing system, where every document ever created is still on file, just getting farther and farther away from the central office. Well, my temporally displaced time travelers, we've reached the end of another quantum adventure in cosmic customer service. Today, we've learned that in the multiverse of astronomical observations, every starlight sighting exists in a superposition of ancient history and breaking news until someone checks the timestamp, which incidentally is always wrong by at least several years. We've discovered that the night sky is essentially the universe's most elaborate delayed broadcast system, a cosmic Netflix where everything is a rerun, and the recently added section contains content from when trilobites was still the dominant life form. Every photon that reaches your eye is a tiny messenger carrying news from the past, arriving with all the urgency of a government memo and the timeliness of a committee decision. Think about this. Right now, as you listen to this podcast, light is leaving your vicinity and beginning its own epic journey across the cosmos. In 8.6 years, that light will reach Sirius, carrying with it a snapshot of this exact moment. You, listening to a show about light delays while experiencing a light delay. Somewhere in the Sirius system, assuming there's anyone there to notice, they'll be receiving real-time updates about your 2025 life sometime around 2033. And if there are alien civilizations in the Andromeda Galaxy with really excellent telescopes, they're currently watching Earth as it was 2.5 million years ago. They're seeing early humans discovering fire, inventing tools, and taking their first tentative steps towards civilization, completely unaware that those same humans eventually evolved into a species sophisticated enough to create both quantum physics and corporate org charts. The universe, it turns out, is the ultimate social media platform. Except instead of showing you what your friends had for breakfast this morning, it shows you what galaxies were doing for breakfast several billion years ago. And unlike regular social media, you can't block the universe or adjust your privacy settings. Everything you do becomes part of the cosmic archive, traveling outward at light speed for anyone with the right equipment to observe. This means that in the grand scheme of things, we're all simultaneously living in the present and broadcasting to the future while surrounded by messages from the past. We're part of an ongoing conversation that spans cosmic time, where every star is a voice and every photon is a word in a story that's been telling itself for nearly 14 billion years. Want to explore more temporal bureaucracy and cosmic communication delays? Visit us at multiverseemployeehandbook.com, where you'll find fascinating science news, deep dives into the universe's filing systems, and our latest blog series, Why Your Messages to Aliens Are Already 100 Years Late and What That Means for Intergalactic Customer Relations. And if you've enjoyed today's chronologically confused adventure, why not share it with a fellow stargazer? Perhaps you know someone who's been waiting for a response from the Andromeda Galaxy Customer Service Department. Spread our signal like ancient starlight, slowly, inevitably, and with impeccable timing. This is your quantum coherent correspondent, reminding you that in the multiverse of cosmic observations, we're all just living in the aftermath of everything that's ever happened, delivered one photon at a time by the universe's most reliable but least punctual delivery service. And somewhere out there in a galaxy far, far away, someone might eventually receive light from Earth that shows the first episode of the Multiverse Employee Handbook being recorded, but they'll have to wait about 2.5 million years if they're in Andromeda, or several billion years if they're really committed to our content and live in a more distant galaxy. When they finally do tune in, they'll probably wonder why humans think workplace humor translates across space-time. The answer, of course, is that bad management is a universal constant. It just takes a few billion years for the complaints to reach the Home Office.
Hello?
Hey, I'm Rob Corrigan, the human who dreamt up the Multiverse Employee Handbook, because I can't stop marveling at how strange and wonderful the universe is, and how often it behaves like a very large company with confusing corporate policies. In a world increasingly run by AI, I think it matters to be clear about what's human-made and what's conjured by machine magic. So here's the straight-up rundown. The host, David, is a professional voice actor. The voice you hear has been digitized using ElevenLabs voice cloning technology, with his blessing and excellent enunciation. The episode thumbnails are created with OpenArt's AI models. Music and sound effects come from Pixabay, composed by human artists. Everything else, the writing, the jokes, the research, is 100% me, human hands, human brain, and occasional human muttering. Thanks for listening, and for being a good human in an increasingly automated cosmos. And if you like this show and make it this far, it would really mean a lot to me if you shared it with a colleague, a friend, or anyone. It's really the best way to make podcasts like this grow, and I sincerely appreciate it.
Rob, do stop ringing after hours. The kettle's on and I'm halfway through a biscuit. Toodaloo.